Hi everyone. I would like to share the details of my mini campervan build with you. If you find my video interesting, please like it, share it with your friends, and subscribe to the channel as there are more episodes coming. During my first year of van camping in the summer of 2023 is used a basic, easy setup of VTOMAN portable power station and 200-watt folding solar panels. I was also able to connect VTOMAN to my alternator via cigarette outlet to charge it while driving. I had sufficient power for a Bouge RV fridge, electric kettle, fans, and various USB rechargeable accessories like lights and a shower pump. VTOMAN capacity was enough for about 2 to 3 days of camping. When I started planning of my build in the beginning of 2024, I wanted to significantly increase my power capacity to support a fully electric cooking setup and ensure 4 to 5 days of off-grid power, even without sun or driving. Several days with no charge may happen quite often in British Columbia, when you are staying on a campground for a prolonged amount of time and there is no sunny skies. One of the options of solving the capacity problem was to add VTOMAN expansion battery to my power station, to expand capacity to almost 3,000 watt-hours. But there was a small inconvenience with VTOMAN power station. It had an auto shut-off feature that cut power if no draw was detected for a period of time, which was problematic for appliances that don't constantly consume energy. Also, in case I need to move VTOMAN outside the van for a few hours for recharging from 120-volt outlet, all electrical appliances in the van would have no power, especially critical for fridge content. So I decided to build permanent electrical system with a dedicated battery to power the fridge and other essential components, independent of the VTOMAN unit, while VTOMAN power station would complement it and work side by side as the hybrid system. This hybrid dual battery approach shaped the overall design of the electrical module. A separate inverter wasn't necessary, as the VTOMAN power station already had one built-in with 3 120-volt outlets, 1,000-watt load capacity, and up to 2,000-watt surges. The VTOMAN unit needed to be easily portable for use outside the van, let's say during power outages at home, for outdoor cooking at a picnic table, or for recharging at an AC outlet. The main battery needed to be chargeable via solar panels and the vehicle's alternator. The VTOMAN power station had to automatically recharge from the main battery after being used for powering cooking appliances. Space constraints presented a significant challenge during the electrical module's design and construction. The cabinet's depth was limited by the need to maximize bed width. I had just enough clearance to be able to shift bed into sofa mode and vice versa. Furthermore, the cabinet's length was constrained by the curvature of the van's sidewall, necessitating a similarly curved countertop and narrower left sidewall. The VTOMAN unit, which protrudes slightly from the cabinet, had to fit under the bed. The bed's foot section even includes a dedicated cutout to accommodate the power station when the bed is in use. To fit the electrical components, I had to create cutouts in the front wall of the cabinet, gaining an additional ½ inch of space for the main battery and Renogy controller. And countertop had to be precisely cut to follow the curvature of the van door and the wall, with minimum clearance to avoid big gap, which is usually a magnet of some small items on top of the counter. When choosing the main battery, I evaluated various options from multiple manufacturers, considering maximum watt-hour capacity within the available space, the dimensions of the designated installation area, safety for in-van installation. I selected the eco-worthy metal case battery due to the following reasons. Safe metal casing, ideal for automotive applications. Large 19-20 watt-hour capacity with a small footprint. Integrated handle for easier installation and removal. However, there were some challenges to solve. Fitting the battery required cutting an opening in the cabinet's front face, which, as it turned out, not only provided the precious ½ inch of necessary depth, but also increased the battery's cooling surface. The lack of dedicated mounting holes or hardware on the battery casing necessitated creating a special plywood-made harness to secure the battery within the cabinet. I researched various battery chargers and chose the Renogy DCC30S due to the following reasons. All-in-one DC-DC and MPPT charging capabilities. It accepts both solar and car alternator power sources and has smart algorithm which want to use based on various factors. Ability to charge the car starter battery when the auxiliary battery is full, a crucial feature for modern vehicles with power-hungry accessories, especially during extended stationary periods at a campground. Compact design. Front panel status lights for quick monitoring. Bluetooth connectivity and app control for detailed information. My limited space presented a couple of challenges. The DCC-30S requires horizontal mounting and adequate ventilation for its passive cooling system. Due to space constraints, I had to mount it vertically in a space filled with other electronic parts, which restricted airflow. To compensate, I added a 120mm ultra-quiet fan behind the unit's cooling radiator for forced air ventilation. To achieve a flush mount with the cabinet face, I built a custom removable frame to house the charger and its fan. The frame's rear panel accommodates fuses, the Renogy Bluetooth module, a power switch for the cooling fan, and a 5-volt transformer for the ventilation fans, which are mounted over the driver and passenger seats in front of the car. The Renogy ONE Core display is another valuable addition to my setup. Powered by the main 12-volt battery, it allows me to monitor the charger controller, utilize the RV leveling feature, including the convenient option to level the van using a phone app while sitting in the driver's seat. I found this leveling feature particularly useful at the uneven campsites of Kicking Horse Campground in the fall of 2024. The control panel, which looks a lot like an airplane cockpit, crams a multitude of switches and outlets into the limited space on the electrical module's cabinet left side wall. As previously mentioned, this wall's width is restricted by the van's curvature, and the space behind it is equally tight, making wiring a challenge. The panel includes a thermometer for monitoring temperatures inside and outside the van, a 3-way switch for the LED puck light, an in and out fan switch for the ventilation module above the front seats, 2 reserved switches for future additions, such as LED string lights and other potential functions. The Renogy ONE Core display. 12-volt cigarette lighter outlets with dedicated switches for devices like heating blanket. USB-A and USB-C power outlets with a switch to prevent battery drain when not in use. A propane detector. While I don't use propane for indoor cooking, I carry cylinders in the trunk for my outdoor barbecue and need a safety warning if they leak. A reserved 120-volt receptacle, currently in use. Cut-off switches for the main battery, solar input, and alternator input. Compact, high-capacity, up to 90 amps, power source input connectors for solar and alternator charging. I mounted an adjustable cable tie that provides basic cable management near the USB outputs. The adjacent storage compartment holds a bag containing wireless chargers and extra cables. The thermometer's outdoor sensor, which I modified with a magnet for easy attachment to the van's exterior when parked. It's crucial to properly secure the electrical system to ensure safety in the event of an accident. The last thing you want is a power station becoming a projectile during emergency braking. Electrical module cabinet. Secured to the plywood floor using a steel angle on the right side, adjacent to the sink module, and aluminum angles bolted to the plywood on the left. The right wall is bolted to the sink module cabinet for added stability. Main battery. Held securely in place by a custom-built plywood harness, designed for easy removal without requiring disassembly of the entire cabinet. VTOMAN power station, designed for easy installation and removal, positioned and stabilized by the cabinet's front face, with an added block for precise depth placement, secured from above and the sides by a custom plywood locking mechanism with oversized latches. Here are some tips and tricks I used while building electrical module. For the main battery connection, I needed 1 0-gauge all-copper wire, which is expensive and typically sold in long lengths. Needing only about 4 feet, buying a large spool was impractical. I found a solution at Princess Auto, welding cable sold by the foot, available in various gauges. It is a Canadian retailer, but I think similar stores available in other countries. Several wires run from the electrical module to power the fridge, pump, ventilation, and other systems. I used electrical connectors to easily disconnect the module from this wiring network. The regular automotive connectors I purchased from Amazon proved unreliable and poorly made. I then discovered Deutsch DT connectors, designed for robust and reliable connections in industrial and commercial transportation. I'm very impressed with them, and especially like the distinctive triangular connector with such a unique shape. You might notice a magnetic telescopic pickup tool attached to the metal folding arm behind the folding table. Its purpose within my van might not be immediately obvious. It addresses the VTOMAN's auto shutoff feature, which becomes problematic when the bed is set up, blocking access to the VTOMAN's controls. I lift the mattress corner closest to the VTOMAN and use the telescopic tool, inserted through a ventilation hole in the bed's foot section, to turn the inverter on or off. It's a simple but effective solution. I have a few planned improvements for the electrical module. I plan to add a Renogy battery shunt for more accurate battery performance tracking. Fitting it above the main battery will be a tight squeeze. I'll connect the string LED lights to the unused switch on the control panel. This will make them much more accessible for turning off when going to sleep, as their current switch is on the ventilation unit over the front seats. I'll connect the reserved 120-volt receptacle to the VTOMAN inverter output, allowing me to use AC-powered devices even when the bed is set up and blocking access to the VTOMAN unit. Next, episode number 8, Energy Sources. I will cover the following topics. My original simple 2023 solar setup. Why I put 400-watt panels, plus 200-watt extra if needed. Monster draft design. And why keep it simple is the best approach. Panels on the crossbars look cumbersome, but have hidden benefit. Running solar cables from roof to charge controller. Charging on the run, using car alternator as energy source. Smart bidirectional Renogy controller, charges main battery or car starter battery. Running cable from alternator to charge controller.